both Piers and I are going to monitor that. So with that, and then the number of minutes allocated to each speaker for questions after each panelist has talked would be 3 minutes. So we'll have to play it strictly. And please forgive me if I have to cut anybody off if it's going over. I could say 1 minute left after each, for each speaker if you'd like. So without any much more ado, here's Gianfranco Pacchioni.
So can you hear me?
Yes.
And the screen is ready? Can you see the screen?
Yes, I can see the screen. Gianfranco, can I just say one more thing that Piers just sent me? Would everybody else besides the panelists and maybe me and Rajiv and Piers unmute your, sort of mute your video so we can see it better? So everybody can still watch, but the panelists, please keep everything on. Okay, thanks.
Okay, so thank you very much. It's a great pleasure to join this roundtable, which I'm sure is going to be quite interesting. And I mean, I got involved in this business of science and contemporary science and problems in contemporary science. Well, because in my age, you know, after a long time discussing with friends and so on, I tried to, at a given point, to study the problem a little bit more closely, and I ended up by writing a book, which was published in Italian first, with the title Scienza Quo Vadis, which means Where Are We Going with Science, and then it has been translated in English with a different title, The Overproduction of Truth. So the point I'm trying to make in this book, and also in this short presentation, is that things have changed a lot since the time when I started my career in science, when I did my PhD in Berlin in the early 80s. And in the early 80s, we were still working with typewriters. And you see here a typewriter that I used for typing my PhD thesis. We were still using carbon copy, writing letters and things like that. This, of course, it looks very obsolete from one point of view, but it is also important to realize that science was moving at a completely different speed compared to present days. Now, things have changed a lot since then, and let me give you just an example. So when I was in Berlin, I was going to the library almost every day, reading this journal, the Journal of Physical Chemistry. I am a physical chemist, and in 1980, so more or less the time when I was in Berlin, one issue of Journal of Physical Chemistry was published every 2 weeks. So there were about 26 issues in a year, 800 papers, less than 4,000 pages. That was already twice the amount that was published 20 years earlier for the same journal. Now, if you now take just this journal, Journal of Physical Chemistry, in 2019, the journal has been split into 4 parts, A, B, C, and letters. It publishes an issue every week, so there are almost 180 issues per year, 6,000 papers, more than 60,000 pages per year. And this is just one journal in the field of physical chemistry. Many other journals have appeared in the meantime. Another way to show you, I mean, how things have changed over years in the field of science, well, this is a very well-known picture of a famous conference, of the conference on electrons and photons, which was held in 1927. There are only 29 participants, and of these 29 participants, 17 are Nobel Prize winners, and there were others that didn't get the Nobel Prize. Still, they gave very fundamental and lasting contributions to science. Now, at least in the pre-COVID era, the conferences have grown up to very large dimensions. If we stay in the physics and chemical communities, we can go up to 10, 15,000 participants. But in the medical science, there are conferences hosting up to 50,000 participants in a single event. Well, this is not so new because the first person that tried to give a quantitative dimension to science was Derek de Sola Price, a sociologist. In 1963, he published a book where he reported on the total amount of published papers in the 3 centuries from 1650 to 1960. Well, it has been a quite big effort at the time. There were still no computers and so on, but he came out with a number of about 2 million scientific articles which have been published in 3 centuries. However, if you look at the original figures that he reported, where there is already an exponential growth, this is a logarithmic scale, and you look at the years before 1910, the number of papers published, for instance, in chemistry or physics, are just a few thousand. And so the question is, maybe there was not so much science done in the 19th century. Well, that is not true, because if you look at the 19th century, the number of achievements and fundamental discoveries is extremely important and rich. But all these discoveries are contained just in a few thousand articles or books. And you can see a list yourself. So things have changed a lot since the time of the Solar Prize. But in various ways. Here, what you see is a paper which was published in Science a couple of years ago, where what is shown is on one side the exponential growth of scientific papers published, and I will come to the actual numbers soon. But in this study, what they did was something more interesting. They tried to basically establish how many new ideas are reported in these papers. Of course, they did it by checking the number of topics in the titles. And the result is that the number of topics which are treated over years is growing linearly. It is growing linearly if you look at the blue line. If you just look at the real points, which is interpolation, the real points seems to level off. So there is an exponential growth of papers, but if you are a positive linear growth of ideas. Well, the result is that nowadays, there are about 3 million scientific articles. By scientific articles, we mean with peer review, which are published every year. Is a continuously growing number. And well, now the number of production from the US is decreasing, production from China is increasing, and basically converging to about 20% for each of these countries. Now, not surprisingly, with a growing number of articles, there is also a growing number of journals. And in 2018, there were more than 33,000 scientific journals with peer review. Interestingly, the growth rate of scientific journals has been about 3.5% per year in the last years. But in the recent years, let's say last decade, it has grown up to 5-6% per year. So every year, there are 5-6% new journals coming up. Well, here, let me make a general comment. I think journals are an important core part of scholarly communication. They have a very important role because they have to maintain quality through peer review. This is an extremely important aspect of contemporary science because that's what makes science different from many other human activities, peer review. Well, but the numbers of peer review are also become quite impressive. In 2016, there have been something like 13.7 million reviews, which have been done in order to publish something like 3 million papers. So are massive numbers. There are some interesting statistics that I have no time to discuss, but for instance, in the USA, people from USA, we have more review articles than published papers. In other countries like China, many more papers than reviews. So it's the same in India. But you see, some countries are more or less equal number, like Japan. Now, one big issue, of course, is that over the years, over a century more or less, the number of scientists active in the world has grown continuously. And I try to figure out, these numbers may be imprecise to some extent, but they are quite realistic. So there were something like 200,000 scientists in the 1930s, and 2 billion people was the population in the world. So there was one scientist every 10,000 inhabitants. Then the number of scientists has grown rapidly, and in 2013, we probably passed the 10 million scientists, but we are 7 million people. So the ratio has become 1/700. And if you look at the growth rates, in 2050, there should be 35 million scientists, 1 every 2,000 inhabitants. So if you go on with this speed, one day there will be only scientists in the world. Interestingly enough, while scientists are growing quite rapidly, expenditures in research and development is growing, but not as fast as the number of scientists. And this is something that we all have experienced because the competition for funding has become extremely tough. And you can imagine, it is immediately clear from these numbers. There are research programs where the success rate is of 2–3%, at least in Europe, which of course makes it more a lottery than just a fair competition. Now let me come to an important issue, which is related to the scientific journals. Well, what you see here are actually 2 bottles of wine. You can buy in a supermarket in Italy this very cheap wine for a little bit more than €1. And of course, you can buy much more expensive wines. Here I took a French wine, just to be politically correct. And this it costs close to €400. And you wonder why? Why is such a big difference? Because finally, we are always talking of a solution of ethanol in water, 12–13% ethanol in water. So why the price is so different? And the price is so different because quality is different and quality costs. And this is something which is very important because I am also editor of a journal. I am editor of a Journal of Physics, Condensed Matter. And I have a feeling that not all colleagues or scientific researchers in the world realize what is the world of publishing, scientific publishing in these days. Let's take 2 journals, and just hypothetical journals, one with a high reputation and well-established, and one with lower reputation. Well, a high reputation journal can receive, say, 10,000 manuscripts per year, which means you are dealing with 50 manuscripts per day. Well, if you want to decide if you want to send the paper out for review or not, if the paper belongs to the journal or not, you need a given number of editors. Here I put 10 editors, each dealing with 5 papers per day. If you have a high rejection rate, because you have a high reputation, you are a good journal, you publish only 2,000 manuscripts in the end, which means for every published paper, you have to deal with 5 manuscripts, which is the reason why such a high quality has a high cost. And of course, on the other hand, you may have a journal which is receiving much less manuscripts. I said 400 in a year. Let's make only 2 manuscripts per day. 1 editor is enough. You cannot afford to have a high rejection rate because otherwise you publish too few papers. So you have only a lower rejection rate. And that is, of course, in terms of efficiency, much more efficient. But it is also low selection, lower quality, lower cost. So there is a cost associated to every human activity, including scientific publishing. In the last 2 decades, we have assisted to the phenomenon of open access. And I want to spend a few words about open access, trying to be as rational as possible and not emotional. Because open access has, I think, some advantages, and as every thing has also some disadvantages. The main advantage of open access is, of course, that it's open. Everybody can access the literature from everywhere without any copyright and so on. In my view, there is another potential advantage, which is the fact that in order to pay for the review procedure, which we have seen is a costly procedure, there are publication charges. And that could be a limiting factor in the total number of papers that we want to publish, because if I have to pay for every paper I publish, I really have to think if I have the money, if it is worth to put in the money to publish that paper. So that could have a positive limiting factor in the number of total papers published.
Gianfranco, 1 minute.
Yes, please. 1 minute? Oh,
1 minute.
Okay. Well, we started a bit late. No, I think we are, okay. I will try to be fast.
Okay.
Of course, the disadvantages are that open access is free to read, but not free to publish. And so there would be a kind of discrimination toward less funded groups. It introduces a monetary transaction between authors and publishers. And also it has created the very detrimental phenomenon of predatory journals. Of course, there are various possible solutions, but probably the most important one is transformative agreements. Okay, so we are going to the fact that we are in a market. And how to evaluate performances in a market? If you have a TV program, we measure audience and share, which is a measure of how many people are watching the program, not how good the program is. Today, in a market-driven scientific environment, we have also a kind of similar way of measuring performances, which is measuring papers and citations. Many papers and citations, successful scientists, which is a market-driven approach. This is on my last slide because there is, associated to modern science, there are a number of problems, which I think are the real severe problems, which are ethical issues. And here I just listed the most important ethical issues, and we have no time to discuss them, but these are all very detrimental because these issues may create a reduction in trust in science, which can be very problematic in society. Okay, so that's the end. So science in the past was an activity for few people, very passionate, highly motivated, with a high talent. Like here, you see just two guys going to the top of the Everest in 1953 for the first time, Sir Hillary. Today, you can go to the Everest in a commercial expedition, and you see there's a picture taken last year. So you go a big crowd to the top of the mountain, and you only have to pay a lot of money to get there. So it's just a way to represent the changes that occurred over time. So sorry for exceeding my time, and I hope I provided some ideas to discuss. Thank you.
Thanks, Gianfranco. Great talk, great introduction. I would like to open the discussion amongst the panelists. And if anybody has a question, I see Laura Greene already has a hand up. So go ahead, Laura.
Thank you. I've been your fan for a long time, Gianfranco. And I just want to say that I'm going to touch on the pathological versus psychopathic science in my short presentation. And I would like to continue the discussion with you because I've been writing a book about this in my head for almost 2 decades. But thank you. That was a brilliant talk.
Thank you. Anybody amongst the panelists have any other question? Okay, so maybe we can wait till everybody is done and the general audience can ask questions. By the way, I want to remind again, if anybody from the general audience have questions, please put it in chat and then we can participate after all the panelists are done. So then I'll move up to Henri Alloul to give his presentation for 5 minutes, followed by a 3-minute discussion. Henri. Henri, did you unmute your speaker? And we don't see your screen. Okay, now we see your screen. Go to your presentation mode and.
In the presentation mode.
Okay.
Do you hear me?
I can hear you now, and which means, and do you want to go to your presentation mode or?
I am on the presentation mode. Is that okay?
It's okay. You could click on the hourglass and it'll make it bigger. This is okay also.
This is okay. You see the things.
We see it, except you have the sidebar. But if you want to get rid of that, you can just click on the hourglass or the presentation icon.
Yeah, I am in the presentation mode.
Okay.
Okay.
Go ahead. Please start. 5 minutes.
Okay. So I just try to go on in the line which has been started by Gianfranco. We have seen that there has been a strong evolution in the publication processes and the communication between scientists, and this in the specific field of condensed matter has been really enlarged by the appearance of ITC superconductivities in the 1990s, which have really increased the number of publications and at the same time as the information technologies evolved. And at that time, while before the ITC, the communications were governed by preprints and by journals which were making a difference in time scales. When we arrived to this ITC period, the communication had to go through a different way. So the speed of communication has been governed rather by the archive than by the journals. And this is a point which has, okay, I have, this has really changed the situation. So what I want to discuss now is all this situation has driven the idea that one should do to simplify things. And so bibliometry has become very important. Of course, it was in the past, the bibliometry was implicit. When you were looking at papers, you had citations, but you didn't count the citations. This was not that important. The only thing that citations were giving is just allowing you to go to the paper and to be able to understand the origin of some of the ideas, but we were not counting the citations. And this has been really a new situation when one began to count the citations that a paper received. And this, I think, has been a new thing which arrived on the market. The second point has been the beginning of the impact factor. And of course, everybody knows that the impact factor is based on the last 2 years of publications of a journal. And so it's something which also had been started very early, but which was not considered as very important. While nowadays, this is really a key in the evolution of the science, because everybody looks and can publish in the journals which have high impact factors. And the main problem, which I see immediately, you need to do high statistics or anything, you know that this is a short-term evaluation. You evaluate the impact of a work on the last 2 years, which is a very short time in science. And what does that measure? That measures the visibility of a work and not at all its reliability. Reliability is a long-term situation. An idea becomes secured when it has passed long-term and not on the short-term period. So the second, the second index, which is quite used, is the H index, which qualifies scientists. But
Henri, sorry to interrupt. Are you trying to change your slides at all, or you're still on the first slide?
No, I changed.
So it doesn't show.
No, oui, on ne peut pas voir les diapositives. On ne voit pas le mode de présentation.
I don't know why. Je ne comprends pas pourquoi, c'est dommage. Alors peut-être que je vais essayer de le faire comme ça. On va voir. Est-ce que là on le voit? Do you see the slides there?
We just see the first slide.
Wrong screen, I think.
Yeah, now we see the second slide.
You see the second?
Now we see the second.
Yes.
Okay, so this is the one I was discussing. Sorry, and something arrived. I don't know why.
And also keep track of the time. You're running out of time.
Yeah, but of course. So do you see this one now?
Yeah, we see it.
Oui.
Okay. So this is the situation which I want to. So okay, I am no more in presentation mode. So what was, if you looked at the situation before the 1990s, a paper was something like that here. And this paper had one author. Nowadays, this is what the situation for a typical paper which will be published in a high impact factor journal. And you have a list of 25 people signing the paper, and you have 17 institutions. So you see that the evolution of scientific work has been extremely important, and we are arriving a completely different type of situation, while the number of authors of a paper was about 2 in the past. Now it's, the average in 2015 was 7. But you can look in most of the high impact factor journals are teams of 25 people. So big question, if you do bibliometry, is there a correlation between the number of papers and the citations and number of authors? Obviously there is. There are many studies have been done. You go to Scholarpedia or Wikipedia, you will find immediately that there have been many studies showing that the number of citations is completely first nowadays because people have learned how to do. And this is what I mean when I say that as soon as you define an indicator, the people know how to first it and how to game it. And so this
Henri,
is
1 minute. 1 minute, Henri.
Yeah, okay. I'll stop. So next thing is what is this H factor, the H index? Everybody knows it in the community. We know that it is the number of papers. H is the number of papers which got H citations at minimum. And of course, here again, you will find a lot of work which show that this index can be first, can be modified. You can do anything with this number. And there are some consequences which I illustrate here in a funny case. Compare the number, the H index of Einstein 100 years after he started his work, that he's dead, of course, etc. It's about, his number is about 60 today. And this guy, I don't know whether you know it, but probably you heard of it. This is the guy who decided that chloroquine was to be used against the COVID. And this is a good, considered a very good French epidemiologist who has an H factor of 120. So how this guy could reach this number? Of course, he knows how to play with TV. And so to get a high H index, you have to be able to manage with TV. This shows an extreme of a situation which tells you that this H index is bogus.
So Henri, you'll have to wrap it up soon.
Okay, I have one more. Which
okay, go ahead, please.
Which is the fact that the use of bibliometry has very profound consequences. It has changed the way people do science. This is really the big problem. And the reason is very simple. You cannot qualify scientists with a single number. A single number means trying to find homogeneity rather than to promote diversity. The second point is that the market time scale is very different from the research time scale. So using marketing type of methods is killing even the idea of what is a scientific work. And this can be illustrated by many consequences which I list below concerning the journals. If all journals try to meet visibility, they are going to be a little bit uniform. They can take different names, but they are going in the same directions, and you could see it immediately when you begin to see that Phys Revelator applied the same rules as Nature. In the recruitment of funding of young people, you are immediately reaching situations which are crazy. That is, the same people are in all the short lists in any search committee for a position. And are you going to qualify these people only with one number? You could at least put other numbers. Very easy. One could be the average number of people who are of authors in the paper, but which number are you assigned to diversity, to curiosity, to passion? Really, one has to do another way than using bibliometry. Concerning education, it's even worse, and this is really my concern. One is educating young people to run into this kind of situation. The only thing a student wants today is to publish in Nature or Science. If he doesn't publish in Nature or Science, he
Okay, so
okay.
Henri, so we can maybe we have to finish now.
Yeah, I just want to finish because I am raising questions and I hope we will be able to discuss them after. This is the point. Okay.
Okay. So thanks very much, Henri. If anybody from the panel has any quick question, otherwise we wait. Anybody have a question quickly? Just from the panel itself.
Can I just speak up?
Yeah, go ahead.
Okay, sorry, I raised my hand. So I think just a comment. I think what is really alarming is that we are not just teaching the young people incorrectly, but we are turning off many of the young people who just don't want to compete in this way. And I think that's what harms science most, that the people we would like to have in science, who really would like to work as it was possible some time ago, they are not going to stay in science, and that's really a shame.
I agree totally with this point.
Okay, so anybody else from the panel have any questions? And I see a couple of questions from the audience, but we'll get to them after we finish with the other talks. So the next talk would be by William Holden Thorp, from Holden Thorp, and 5 minutes for the talk and then a few minutes for discussion right after.
Sure.
So please, Holden Thorp, go ahead.
Yeah, well, thank you for including me in this, and thanks to Laura and you all. I think it's really encouraging that you're discussing all of this. I was a scientist in biochemistry for my career. Then I went into administration, and I was a chancellor and a provost at two outstanding, very, very productive research universities with $2 billion between the two of them a year in research funding. And then I had the high honor of coming to be the editor-in-chief of the Science family of journals. And so this has given me a perspective on this, you know, my own career, which is Gianfranco nicely laid out as something from the past. But during the time that I was an administrator, helping scientists achieve what they wanted to achieve, and also setting the budget for the library, which I did at two outstanding research libraries, and then moving into this job. And I mean, I think you all know a lot about the Science family of journals. We're very different from Cell and Nature. We only have 6 journals. We're nonprofit. We do generate a surplus that goes to fund the great work of the AAAS and lobbying Congress and getting more scientifically sophisticated people in government and promoting international science collaboration. And we're proud to generate a surplus so that they can do that. We don't generate a surplus for our shareholders the way that Cell and Nature do. And we're also much more different in that we are not pursuing a strategy that I am very worried about, and Gianfranco and Henri both laid out nicely, that you know, volume is a good thing for science. So we do have a gold open access general journal, Science Advances. It's the most selective of all of its brothers and sisters, much more selective than Nature Comms or Cell reports or scientific reports. We have no ambition to grow it any bigger. I don't think that there are enough papers out there for all of these journals to get much bigger. So, you know, and I worry about the other mega gold journals being pushed to grow larger. And as you see all this stuff in open access, I mean, one thing to ask yourself is, you know, how are Elsevier and Springer reacting to this? Well, they're not raising as much of a fuss as you might expect. And the reason for that is that, you know, their goal is to use their top journals to recruit papers that they can then, if they don't get accepted, get funneled into an APC journal that can generate revenue for them. We are not doing that. We do funnel a few science papers to Science Advances, but Science Advances is its own interesting, academically led journal that is very different from its competitors. And it does have a higher impact factor if you care about that, but more importantly, you know, it just selects fewer papers, and it's also done by academic editors. So, you know, what worries me about this situation, and I'm so glad you're talking about it, because in all the years that I was an administrator, you know, faculty came to me with all kinds of interesting problems and things that they wanted me to solve. Not once at WashU or UNC did a faculty member come to me and say, I'm really worried about what's going on in science publishing, and I either want you to destroy all the subscription journals and go to open access, or I want you to preserve them. I mean, I never encountered a faculty member focused on this. So the fact that you all are talking about this is good, because if you don't, what's going to happen is the commercial publishers and the zealots who are really focused on open access, the folks at PLOS and eLife, for example, they're strange bedfellows, because the eLife and PLOS people are very progressive, you know, wanting to give away everything to the world. And Elsevier and Springer are seeing how they can make money off of this. They're allied, and the faculty are mostly not aware that this is going on. And so, you know, since, you know, my favorite administrative job was being a provost, because I was the advocate for the faculty. And I'm really worried that this revolution in scientific publishing is going to happen without the faculty having their say, because this is all going on in the background, and it's among isolated communities. And, you know, we believe that the best thing is to have selective society journals that are nonprofit, that aren't chasing volume. That means I'm going to have to charge your librarians for the subscriptions. I think for science, you know, they'll probably continue to be willing to pay for it. I worry about some of the other societies that will be in more danger getting their subscriptions. But, you know, I feel better having done 14 UNC and WashU budgets. I feel better taking money from the library than I do taking it from your lab. I don't want to, if you want to publish in Science Advances and you got $5 grand to give us for the paper, I'm glad you have that option, but I'm going to fight with everything I've got to make sure that that's not the only option. Because for 140 years, science has not had a means test for whether you can publish your paper with us. We don't ask you, we don't even ask you if you have a subscription or if you are at a university that has a subscription. And that would be a terrible thing for us to lose. So I congratulate you on focusing on this, and I'll just finish right here. I congratulate you on focusing on this. I think it's an extremely important topic. And if the faculty don't decide where you all want to be on this, this is going to get worked out without you, and you might not like where it ends up.
Thank you, Holden. So that was nice to hear. And Laura has her hands up from the panel. So please go ahead, Laura. You have to unmute.
I have people fixing my air conditioner, so.
Yeah.
So thank you, Holden. You really hit some things right on the head, and I just want to point out that just like whenever we used to take taxi cabs, we talk about outreach and trying to get science across. I spend a lot of time talking to the faculty, because you talk to the young people or faculty or anyone, and they think that, well, why should there be any charges at all? It should be free to everyone. And they don't understand what an APC is. So I think we all are charged with, I'm glad we're doing this, and we're all charged with that. And also, well, I think I'll just stop there. Thank
Yeah,
you.
I mean, one danger, and this is why it's good that your group is discussing this, is that, I mean, the money for, even for us, but certainly for the big publishers, is mostly in biomedicine. And that's where there's more money around to pay APCs.
Mm-hmm.
So the other thing that's going to happen if you all don't engage is that, you know, the publishing industry will be designed for biomedicine. And if it works for physics or chemistry, then great. But if it doesn't, you know, it's not going to change. It doesn't change the profit situation.
Okay, anybody else have any questions from the panel?
There's also the problem that places like CERN and other organizations insist on open access, and they will help the societies pay for part of the open access, but we don't know how long that's going to happen. We have that at Science and we have that at APS, and that's something else that really worries me, but we can address that at a later time.
Yeah, I mean, Plan S just made another big announcement, and that's another whole huge topic, but yeah.
Okay,
sure.
so Gianfranco has a question, I was told.
Yes, thank you, Holden. Very nice what you said. I like it very much. Of course, you highlighted very clearly what is the policy of science in this respect. But I want to ask you a question, because this distinction between, let's say, societies and commercial publishers, it is not so clear to me if it goes to our cases. For instance, I am thinking of American Chemical Society, because they have produced an increasing number of journals. Every year there are new journals. And if you look at the budget, I think a couple of years ago, they had something like 500 million income, basically, and most of it is from publications, and only 20 million was going back to fellowships, for instance. So it is a little bit more difficult for me sometimes to see this distinction, okay? Which is clear in some cases, maybe less clear about some other cases. I don't want to blame ACS, which is a great, I'm a member since many years, but this is a fact that, for instance, maybe because they are also working in the field of biochemistry and bio stuff, which is growing very fast. So I wanted to know what is your point of view?
Yeah, I mean, I grew up in the ACS journals too. If it weren't for Jax, I probably wouldn't be here talking to you. So I think that ACS for sure has done a great job with their business. There's no question about that. I don't know as much about APS, but Laura could tell us. But some of the other societies, you know, the Society for Microbiology, the Association of Psychological Science, a lot of these are, you know, entities that have about the same number of journals that we do. And it's also true, I mean, these are big journals that don't have to worry about being disrupted, but New England Journal and JAMA and Annals, all of those are society journals, which, you know, for all of us, I mean, for New England Journal, for JAMA, for AAAS, for Annals, if we don't generate our margin, you know, those societies go away, or, you know, or they have to sell us to a commercial publisher. And, you know, I guess my career goal is to make sure that Laura, who's on our board, doesn't ever come to a board meeting where they decide, you know, we're going to partner the journals with Wiley or somebody like that, because that would really, nothing against Wiley. I mean, I published a lot of Angewandte Chemie papers when I was coming up that were helpful to my career. But, you know, our character as a nonprofit set of journals is very important to us. ACS, I agree. They're kind of in the middle between a commercial publisher and us. You got to give them credit for knowing how to build up their business. And, you know, I published a lot of JPC papers too, both in the when we just had one and then in version C.
Okay, so it looks like Henri had a question. So maybe this is the last question before we move to the next panelist. So Henri, go ahead and unmute.
Can you hear me? Because I had a problem.
Yeah, we can hear you.
Yeah, okay. The thing which I didn't say, and that I wanted to say is that we are responsible. We have to be involved. The scientists are really playing a large role in the decision to take into account the impact factors, the H index, etc., etc. We have to be able to work differently. This is really the situation, because we are, by this way, we are modifying the way science proceeds, and we are killing the ethics of science if we don't take care of things differently. This is my point, and I am pleased to hear that editors could follow us in this direction.
Well, not all of them will, but I will. Yeah.
Well, okay.
Khandkar, you're on mute.
Khandkar, you take over.
I think he was asking for questions from the general audience. You muted Khandkar.
Okay. Khandkar, you're on mute. He can't hear us.
We don't hear you.
Oh, sorry. So Eva, it's your turn to give the talk, and then we'll have a few minutes within the panel, and we'll have enough time for general audience later on. Thanks.
Okay, do you see the slides?
Yes, I see the slides and I hear you. Thanks.
Okay, perfect. So I'm going to continue on some issues that we already touched, in particular how the way we set up the evaluation of science changed the way of doing science and the people that stay in science. So let me start from very long ago, when David Merming was writing this column, What's Wrong with These Prices? He wrote that at the time, that it seemed evident to him that the system of pricing has gone completely amok, absorbing far too much of the time and energy of the community in proportion to the benefits conferred. And yet he wrote at the time, nobody complains. Why? Well, nobody complains, it explains, because we don't like to question the system in which we are in, neither our choices or the one of our colleagues, independently if we got benefits or not out of it. But the question is that somehow we got stuck in a similar dilemma, in a similar situation where we have a system which was set in place, as we heard, many, many decades ago. But now it's time, I think, it's highly time to analyze critically if it really benefits science or not. What do I mean by benefit science? We have heard that we went from passion to market. Well, I still believe that most people that enter science, they do it for passion, but they find themselves inside a market in which the product, to simplify the situation, is papers, while it should be content. And of course, make the accent on paper simplifies our work. But the question is, this science improve with this system, or by using this bibliometric system, we somehow replace what we want to optimize with some number, and we came to believe that there is some invisible hand that will take care of the problems for us, like the invisible hands of Adam Smith. So what is the problem with wrong incentives? Well, when we have a market and we have incentives, they produce some selection pressure, which means that a certain type of behavior is rewarded and other type of behavior is not. Maybe at the beginning, there is an average, people are still doing more or less what they think, but after it strongly changes how we behave. And in particular, the people that don't fulfill a certain type of rules, they are selected away. So they either, so in particular for the new generation, don't stay in science or have to change their way of acting. So what pressure do we have? We have pressure, for example, to build huge groups, which leads sometimes to monopolies of a certain aspect of science. We have the pressure to follow our topics, which means that science is driven by passion and hypes rather than by curiosity or what we think is really important. we have a high pressure to sell, which leads to oversell. So the question, we're going back to David Mermin, is, are we wasting time of energy? Are we on kind of Picherian runaway where we create some feature which looks nice, but it's a hampering progress in reality? Well, there is also another associated question. Yesterday, we were celebrating Anderson from the book More and Different. He poses us this question. Is it really true that more money means that we are doing better science? So what are the risks of present incentives? If we go from selling to overselling, well, there is a full spectrum. It starts from obfuscation of results, maybe to present a bit more cool way, but at the end, making the papers less clear and less transparent, so which is a bit the opposite of what we should do in science. We should make things clear. And it goes all the way to the loss of scientific integrity, which then appears in extreme cases as big frauds. So we know a very famous one some now decades ago. What about hypes and monopolies? Well, it means that in practice, the full community is working on delta function on some spot in the universe, while we don't look at anything else because it's convenient to work there. There we get more citations, more attention. So as a community, we are, however, putting all eggs in the same basket. We are not promoting free exploration. And in fact, this I think is the biggest problem, that all these effects, they produce a loss of diversity, loss of free exploration, loss of independent minds, loss of patience, because if you don't fulfill the criteria above, especially if you are a young person, you don't have a chance to stay in science. And if you're older scientists, maybe you don't get grants, maybe you are isolated. This is very, very dangerous. For example, a certain type of scientists, which are, let's say, the quiet people. This is the description of Anderson of John Bardeen. John Bardeen was an extremely quiet man. Nonetheless, this quiet man led the way into two earth-shaking developments. Still, to most of the world, is John Woo. So this type of free exploration, independence, and passion risks to go extinct because it's not convenient in our market. It's not convenient to do things which may lead to failure or which to explore a new path because the risk is that then we don't get the grants or we don't get the position and so on. So in my opinion, we need to change paradigm. We need to stop to think that this is the only way that things can be done. That the way we evaluate science is the only way that makes science evaluation possible. Of course, we do need science evaluation, but we should find ways of change the focus from these numbers, as was already said many times, to the content. So we should try to optimize the content. So this is in some sense also good news. We have incentives. If we recognize the problem, which is still the first step toward changes, well, we can also change incentives. And we have to go in that direction. So very long ago, Feynman gave this famous speech at Caltech. He was concluding, wishing to the new generation that they could find a place to work where they don't feel forced by a need to maintain position or financial support to lose integrity. And he was concluding, may you have the freedom. But after many decades, I think that we know where we are going. And we have somehow to find a way to not put the young generation in particular to that corner, because otherwise we are driving out of physics many brilliant minds which could give very important contributions. And here I finished my presentation, so if there are questions.
Thank you, Eva. So if any of the panelists have a quick question, please go ahead and ask. Anybody from the panel? Let me check.
Laura?
Nobody has a hands up.
I do.
Okay, Laura, please go ahead.
Thank you, Eva. That was really great. I just wanted to add one thing, that one of the measures of reliability of something that's being published if they publish it first. I call it science by press release. And we all know examples of that, whether it's superluminal neutrinos or cold fusion. And so I want to thank you for bringing that up.
So you mean
Thanks.
exaggerations that, okay, of course, these are famous examples where you would wonder if maybe thinking 6 months longer, you would have avoided big news about the superluminal neutrinos and found the problem in your experimental setup without making big claims. And I think, okay, this is something which is highly pushed by the system, because of course this is if you are right, you get a lot of attention, then you get a lot of citation. You will get it even if you are wrong, because after people will say it's not right. So I don't know, it's a situation where you win to make claims, because then you are the first, and you lose if you are too careful, and it's a dangerous way.
Okay, so I think Greg Bobinger has a question. So Greg, go ahead.
I'm particularly pleased that you brought up the issue of overselling as a risk under the current paradigms. And over the past 35 years, if there's one big change that I've seen in this whole arena that we're discussing today, it's that referees seem to feel that their job description is different than it used to be. For experimental papers, decades ago, it was much more, are the data well taken, convincing? Is there a gap in the logic in the data? Are the data worth publishing? There's much more focus now on the 3 paragraphs at the end of the paper that Horst Stormer used to always tell me, if your data are good, it doesn't matter what nonsense you put in those three paragraphs. And in his Nobel Prize winning paper, those 3 paragraphs were all wrong. They talked about Wigner crystal. And there are years-long arguments with referees that persist because you haven't cast your data in the form of an argument for or against stripes or some other theory du jour. And I really do feel that we suffer because we're not allowing great data to be published and then debated in the broader community in a timely fashion. I find that with experimental manuscripts these days, it's the desperation of the first author or the last author to publish and to weather the storm for a year to get through these iterations of what I feel are largely misguided referees.
Thanks,
Yes,
Greg.
well,
Yeah, go ahead.
Okay, I agree. Of course, the journals also play a role in that because, well, if you have to publish in certain journals, you are required to declare that it's a Nobel Prize discovery where you've done maybe very good work, but it's not. Then so it's connected. So I would agree. I think that papers which are more, let's say, saying what we are doing, and so that you can actually know if they are right or not, and it's not hidden under the carpet between a cloud of big claims. I think we should go back a bit to that direction.
Okay, thanks. So I think we'll stop for now and then go on to the next.
Does Holden have a particularly valuable perspective on this?
Well, I just wanted to add, first of all, thanks for a great talk, that you'd be surprised how many people write to us and want us to retract the press conference. Well, we can correct the paper, but we can't do anything about the press conference. People get very frustrated about this. They'll write in and say, you've got to do more because they gave this press conference where they're exaggerating. If the paper's right, or if there's an error that we correct, or even if we retract it, that's all we can do. We can't do anything about the press conference.
Thank you. So I think we should move on just to have some more time later on. So the next speaker is Karl Ziemelis from Nature. Karl, please. Okay, so we still can't hear you.
I'm unmuted.
Oh, okay.
Now, I think.
Okay.
Sorry, I'm still getting used to this online.
Yeah, we all are. Thank you.
Anyway, can you see my screen? Okay.
I see your screen, and we can see and hear you. Thanks.
Fantastic, excellent. Okay, great. Well, first of all, thanks very much for the opportunity to come and talk to you all. I'm going to take a slightly, well, like Holden, I'm going to be giving a sort of editorial perspective on this. I'm going to give a slightly different one. I'm not going to get into the issue of society versus commercial business models. That's a meeting in its own right, and you'd be surprised how varied the views are, even within one particular organization, let alone between organizations. So I'd leave that one for another day. I would, however, refer back to something that applies both in society journals and in commercial journals, is that something Gianfranco mentioned right at the start, is that selectivity costs. If you have a selective journal, it costs money, it costs resources, and that's often not really as prominent in the discussion as perhaps it could be. Anyway, what I'm going to talk about, hopefully briefly, is a perspective on that wonderful metric, the impact factor, from I should say a high impact factor journal. I'm not going to apologize for working at a high impact factor journal, but what I am going to try and do is explain why this is a metric you should just basically simply ignore. Well, first of all, just to kick off, highly selective journals such as Nature, such as Science, are noted for their large impact factors, but that their impact factors are as high at the high end of the spectrum should really ultimately be no surprise. Again, we're coming back to that issue of selectivity. The journals are aiming to represent the most interesting and impactful work in the fields that they cover, and if they're indeed successful in achieving those goals, that'll be reflected in the usage statistics, such as the citations of the papers they actually publish. But again, the point I'm going to be making is a quantitative journal level metric for assessing research. It's not particularly useful. Anyway, moving on, if I can figure out how to do that. Yes, okay, quick recap. Why be selective in the first place? Well, forgive the cliche, in the case of Nature, this is very much part of our DNA. It goes back to our original mission statement back 150 years ago. From the outset, we had two principal purposes in mind. The first was to bring to the attention of the wider audience, the general public, as it were, the great works of science, what the scientists were doing behind the scenes. But secondly, and this has increasingly become the more central part of our mission as we become, as the nature of scientific publishing has changed, is that acting as a platform for those scientists to actually discuss amongst themselves the work, and with a view to helping progress that going forward. So in practice, what does this selectivity amount to? Well, I'll just give you a very quick slide showing what I think is pretty much the popular perception, or the wide perception, of how selectivity works at journals such as Nature. A paper comes in, editor maybe does something, the paper is rejected. There's a little bit more to it than that. Ultimately, what editors are trying to do is indeed, from the various papers that are submitted to them within their respective fields, they're trying to identify those papers that are likely to have the greatest impact going forward. There's various criteria that can be applied to this. Probably the single biggest one is we're trying to tease out those papers, not those papers that are curing cancer or proving Einstein is wrong or anything like that. What we're looking for are those papers that are tackling within their discipline one of the key disciplinary goals and making substantial progress towards answering that. If they answer it, even better. There are other classes of papers, the discovery papers, which potentially are opening up new and important directions of research. So part of our job is to try and look at those papers and try and say which ones have the greatest potential for opening up new research fields, new areas of endeavor. Then there are other factors that can come into play as well, though the first two are probably the main ones. The other factors are things, does the work have impact beyond its immediate field? Are there researchers in other disciplines closely related, more distantly related, who could potentially get something out of this? Is it addressing a question with broad societal relevance? So in principle, any reader could look at it and say, okay, I can see why that's important to me. And then there's the occasional, fairly rare class of paper, which maybe is not addressing a big disciplinary goal, maybe is not discovering something new and exciting, but it's just so damn clever, you can appreciate it for its own sake. they're rare. Anyhow, but the upshot of that is only about 20% of the papers that come in go through to the review process, and ultimately, by the time the review process has done its job, only about 7 or 8% of the originally submitted papers make it through to publication. So that's the essence of the selectivity that Gianfranco was mentioning, and which ultimately is responsible for why certain journals can have impact factors as high as they are. So if those criteria are successfully applied, the published papers, as I mentioned before, are likely to be at the high end of the citation distribution for their fields, and that will have a net positive effect on the journal impact factor. But these are the points to really keep in mind. Citation activity varies hugely from field to field, not just in terms of the volume of activity, but on the timescale of activity as well. Some papers accrue citations really quickly, some over a very extended period of time. And even within a discipline, even within physics, there are going to be areas of physics right now, some of the moire lattices in the graphene systems are going through the roof with citations. Other areas, even good established areas like high energy physics, not pulling in the citations at anything quite the same rate. That doesn't mean one paper is better than the other. It just means averaging across the bulk makes no sense at all. Throw in other disciplines as well, and that average becomes increasingly meaningless. And you know, I could say, almost anecdotally, when I started at Nature back at early 90s, one of the tasks I and my colleagues were given was to really try and boost Nature's visibility and presence within the physics community. We were predominantly seen as a life sciences oriented journal at the time, but we wanted to represent the whole of science. The way I used to phrase it to many of the people I met at the time was, I'm on a mission to reduce Nature's impact factor. Anyhow, moving on. Other reasons to be very, very wary about journal impact factors, particularly journals that have a relatively low volume of output. And again, we're talking about highly selective journals there, is one blockbuster paper can have an inordinate influence on the journal average for that year. It can many percents of the impact factor can be pointed to as just one single paper. And I think a third point, I think this was touched on in some of the earlier talks as well, is that a journal becomes popular, becomes highly visible. That visibility itself can give papers a citation boost. So you can have a couple of papers from different groups, but doing essentially the same things, one appearing in a high impact journal, one appearing in a more niche specialized journal. To all intents and purposes, they're the same paper. One will potentially get cited a heck of a lot more than the other. It's completely unrelated to their intrinsic value. So again, now just to wrap up, touching on what Eva said, ultimately it is the research itself that matters, not where it is published. Having said that though, I do of course continue to hope that a lot of the best research will continue to come my way. So on that, I will stop.
Thank you, Karl. Do any of the panelists have any questions at this point?
Yeah, thanks, Karl. So one of the things that science and nature have in common is, we have professional editors, and a lot of the society journals have academic editors. So, I mean, I have my own views on this, but how do you see that play out from your perspective as it relates to all the things we've been talking about?
I'm not saying there's any fundamental advantage to one over the other. Obviously, I'm a big fan of the system that we use, and it's also very closely related to the system that you use as well. I would say one, because we are publishing a relatively small number of papers on a weekly basis, spanning a multitude of disciplines, it's helpful to be in a position where we are not so closely tied to one discipline or the other in terms of making that editorial selection, because there is, I'll be honest, a lot of subjectivity in what we do. When we're making those value judgments about where a paper fits in the grander scheme of things, you'll potentially get different answers according to different people that you speak to. We at least have a position where we're able to take a bit of a step back and see a much broader perspective, well, not a much broader range of materials than perhaps an academic editor would do, who would be much more attuned to their specific discipline. The downside is that if it's not, there is a risk that as editors we could miss, and we probably do miss, important developments, critical developments that maybe the authors hadn't been particularly clear at expressing or contextualizing what they were done, and the editor, him or herself, was not as fully up to speed with what that community was doing. There's a possibility that we could miss a little gem coming past our desk that way. But on the whole, I think it's more the global view is probably what I would say is probably one of the biggest benefits of such an approach. But I'm not saying that diminishes in any way the academic approach to editing as well. I think they both have their place.
Okay, so in view of time, we still have Laura to talk, but I'll just take one more question from Eva Pavarini, and then I see two more hand raises from Victoria Gianfranco and Silke. We'll wait for those maybe after Laura's talk. So please go ahead, Eva.
Okay, sorry. Yeah, my question is, so you're saying you still hope that all the best research comes your way, but so which I think I understand as a journal. But how do you conciliate this with the choice of making cascade journals? So the number of major journals exploded along the years.
Yeah, I think that there are. I can't speak for the business reasons for that, and undoubtedly there were business reasons for that. As editors, I will be frank. When we started launching the journals, there were reservations amongst the editorial team. However, I think we have grown to some extent like having that portfolio of journals available to us. And this, again, it touches on something that Gianfranco said right at the start, is that for every paper we're taking through to review and to publication, there are many, more than 10 that are not being taken through. And some of those, as editors, it pains us to turn them down. Because particularly if it's areas that we've been nurturing and growing and developing over the year. And as the overall quality of the submissions gets better and better and better with the year, obviously there's a long tail, but it hurts as an editor to be turning those down. And if we can at least point those authors to a potentially receptive journal that's part of the same family, we feel a little bit more comfortable about that. But at the end of the day, it's the author's choice. The author ultimately chooses where they will try to publish their work. Obviously, it's not entirely their choice. They have to get through the editors at whichever journal they go to. But yeah, but as I say, it's for myself, I'm speaking mainly for Nature itself. That's the journal I've always worked at, and that's the journal that I hold passionately close to my heart.
Sorry, we should move on to the last speaker, Laura Greene, and then hopefully we'll have few minutes for questions from the general audience. I've made a note of who's been asking, and also Piers is probably keeping some track. So let's go to Laura. Laura, go ahead.
Okay. Can you all see this?
I can see it and I can hear you. I hope the rest do.
So yeah, it is a slightly different Zoom than I'm used to. So
I cannot see a slide.
You can't see the slide.
Yeah,
No,
we cannot
It just says started
blank.
sharing.
So what I couldn't see is which screen I was sharing. Let's try this one.
Yes.
There you go.
Okay, great.
So if I do this, do I lose it?
No, that's good.
Good,
You
okay.
just see the one slide.
Okay, so I've got two topics. I've been in publishing for quite a long time, and I've really enjoyed it, decades as a matter of fact. And so I'm going to, for variety, reach a little past the H-index of this panel, and I'm going to offer a couple of possible suggestions to aid in this, minor suggestions. One I think is more major. And it's always fun to be a little bit provocative. So the first one is a journal club model versus impact factors applied for candidates. I have one slide on that, and then I have one slide with a couple of flashy things on pathological science by Irving Langmuir and psychopathic science by Laura Greene. So this journal model I learned about several years ago by Jochen Manhard. And he applies it at his MPI in Stuttgart for hiring, promotions, and for tenure. And they don't look at impact factors. It's a very simple recipe. The candidate provides 5 papers to the committee. Each committee member, and it could be your entire faculty, any interested party, reads all 5 papers. Each committee member then carefully studies one of the papers. You put 1 or 2 faculty members on one of these papers to really study it. And just like we have our students do, they give an in-depth journal club to the entire committee and any interested parties. This all happens before the candidate's interview. And Jochen likes to say, the interviews are vastly more informative. And I'll tell you, you can really learn a lot by doing a journal club of certain papers where they don't really give you that much information. And you have, where we talked about that, there'll be a big leap from the data to the conclusions. And I see my students struggle with that. And so you'll find that to be very, very informative in promotions, tenures, and hiring. I want to point out that it's very difficult and it's much more time consuming, but it really helps you make better decisions. The question I have, and I don't know the answer, is can this be applied to peer review? The next thing I'm going on to is pathological science versus psychopathic science. It's been an interest of mine for also a couple of decades. Irving Langmuir had studied this for many, many years. And in 1953, he gave a colloquium at GE Atomic Center. And the basic premise is that, you know, we make mistakes. Good people can be human. And they can make a mistake and park their scientific method at the door. The most famous poster child for that is Henri's. They just really believe the truth. This is something that I think every human is going to be guilty of to a point because, you know, you're taking data and the point didn't fit the theory, but, you know, there was something kind of funny with the lock-in that day. And so what do you do about that? Sorry. So one thing that's great is our peer review process. If you peer review in the manner that Greg pointed out a few minutes ago, that's meant to discover those kinds of problems. I personally like to give seminars on unpublished material to make sure I'm not fooling myself. If you want to read about this colloquium that he gave, there's an article in, it's hard to read, in Physics Today that was published in 1989. Now, what I've discovered, and we all know about this, is that there's something that's not someone making a human error, it's someone that hand draws the data. And so my studies and collecting of information, it turns out the American Psychological Association claims that about 1% of the population are psychopaths, which means simply that they don't have the connection of ethics in their brain. So if I steal, you know, 20 euros out of Henri's wallet, I don't think about it again, okay? Now it turns out I've learned, even from my work in parapsychology, yes, that's true, scientists are very, very gullible and are poor at discovering this. We want to believe things. So one thing, this is one of my suggestions, my second suggestion is that we need to educate ourselves and other scientists. How do we pick up that someone is just really frauding the data? It's very, very difficult. And of course, the 2 most famous examples in the physical sciences are Henri and Victor Ninov. Now, I wanted to warn you in my studies about this. It's not that there are 2 different phases and there's not a first or second order phase transition between these 2 states. It's a crossover. Someone can be so egregiously pathological that you got to put them in the psychopathic science thing. And just like there's not a sharp difference between borderline narcissist and psychopath, this is something that makes it all the more difficult to figure out. Finally, I want to end this because I want this to be a short talk so we can discuss. As I said, I would like to continue this discussion, Gianfranco, of course, and anybody else that's interested, because I think we need to understand this better and educate better. So those are my 2 points, and thank you for your time.
Thank you, Laura. So that was great. And is anybody from the panel have questions? And then we can move on to general discussions. So let me see if anybody, Victor Yakovenko had a question, but we're going to wait on that. Let me see if the panel has any questions before that. Otherwise, we'll see. Anybody else have a question? Okay, so let's do this. Let's get all the general audience as well as the panelists to ask questions now. There are several questions that have accumulated through chat and also through raising hands. I'm going to start with Victor Yakovenko, who had raised his hand earlier on. So Victor, would you please ask your question?
Okay, you can hear me, right?
Yes.
Can I share the screen if possible? Or if you can stop your sharing and maybe I can share. Okay, let me see if it works. Okay, share screen.
Let's try to keep it somewhat brief because there's several questions and we are going to run out of time, Pierce tells me.
Okay. Okay, fine. So then I will not share it. Okay, fine. So basically,
sorry.
I have basically 2 pages. I mean, I have two slides, you know. If anybody's interested, I can send you those slides by email.
Sure.
So basically, here's my proposals. I was thinking this for a long time. Some kind of proposal to change kind of the paradigm of scientific publishing. And basically, the thing is, historically, journals perform several functions. Historically, they make things published, make it publicly available, but they also evaluate, they also filter, you know, selection and all that. And basically, my proposal is just to analyze these things, slice them down, and unbundle. Okay, so these 3 different, these are different features that should be unbundled. Meaning the first feature is publish, means make it publicly available. That is performed by archive. If you know, archive makes paper available to public. You do not need any journals whatsoever to make papers publicly available. Now, second feature is evaluation, like peer review. People say it's very important, you know, peer review, etc. Yes, evaluation is very important. So let's separate this function and let us pay for that. If this produces value, evaluation, let's pay for the evaluation of the paper, not for making it public. It's already public on archive. So then as papers posted on archive, and then authors voluntarily, if they want to, they can submit them to some sort of evaluation boards, which are basically the editorial boards, which send them to peer review, you know, they've attached some scores and comments and all of that, and comments get attached to the paper, you know, given evaluation of this paper, the peer review evaluation of this paper, okay? And people also should pay for that feature, for the evaluation, not for publication. It's publicly available on archive already. And third feature is selectivity. Of course, you know, as it was discussed in the first talk, the number of papers is so huge. There is absolutely no way to read these papers. It's just physically impossible. That majority of paper will not be read because it's simply physically impossible. So we need some filter to select papers that we should pay attention to and actually read. So this selectivity, but this is filtering. And this filtering can be done, this third feature done by, again, different organizations. For example, when you do Google search, Google, you know, filters those search results and gives you the most relevant and actually very effectively, right? Okay. So Google does filtering of that search results. Or for example, reputation of institutions. There is a Shanghai Review or, you know, US News and World Report which rank institutions. Or for that matter, New York Times. There is New York Times Book Review, right? New York Times does not publish books, but they publish hugely successful book review. So normal procedure, like in movies, like in records, etc. You first make it publicly available, and then critics evaluate it post factum. And give, you know, your scores and, you know, recommendations, not before facts. What Nature told us, that paper goes to the journals, to the editors, and they try to guess beforehand whether paper will or will not make impact before anybody even saw this paper. Most cases, they say reject the paper. That means nominally means not make it public. Okay, that creates future problems. Like Greg Bobinger said. So authors have to put this fake, you know, overhyped paragraphs to get your paper through the reviewer, through the editors, just even to get it reviewed. And then often, you know, clever reviewers notice this overhype and say, yeah, you have to remove this bullshit. Okay, so you see, so evaluation should be done after, post-factum, it's post-selection, not pre-selection. So here is the proposal. Papers posted on an archive, then editorial boards be transformed or branch into evaluation boards that produce evaluation of the paper. That's voluntarily, and authors pay for, don't pay for subscription to the journals. They pay for just evaluation of papers. That goes from the library budget of the, you know, universities.
Victor,
Victor, we have to go ahead. So thanks for your question. If any of the editors have a very quick response, Otherwise, we have several questions to get to.
Well, I think certainly what you're describing, there are absolutely efforts out there. I mean, eLife is putting forward almost exactly the model that you're describing. And that's why I say, you know, I don't think this is any of this is gonna disrupt science or nature anytime soon. But, you know, these movements are happening and the faculty need to get together and engage in the ways that you won't want to.
Yeah, I'd just add to that as well. Of course, there's also operations like Faculty of 1,000 as well, which do a lot of post-publication assessment, and it has that post-publication filtering element to it. So, I mean, these are all great ideas. How one would implement them in practice, I don't know, but that doesn't mean we shouldn't talk about them.
Okay, so the next question, I think Silke had a hand up a while back. Silke, you want to still ask the question?
Yes, maybe that's to both editors. So,
okay.
Of course, everything you say sounds perfectly reasonable. The question is, what does really the guessing of the impact, what does it really imply? How much do you think you are subject to fashion in science and these things? So can you exclude that this is an important factor?
Okay.
Go ahead, Karl.
First thing I'd say is I think I may have phrased things wrongly. We're not trying to guess impact. I don't think any of us would be able to do that. What we're trying to do is contextualize the particular work and fit that in with what that community is trying to do. And if it looks like the paper is addressing a big question or making progress towards a big question, there is a good chance that such a paper will have impact, but we're not looking at it really from a, will this paper have impact? That's not the question that we pose to the paper. The second thing, sorry, I'm just getting distracted by the background noise. Sorry, I've kind of lost my thread there. Okay, so
fashion or fancy.
Oh yes. Thank you. To some extent, we are subject to that, but I would say largely in the sense that what we publish is ultimately driven by what is submitted to us, and if a field explodes and, you know, you could say has become hot or fashionable or what have you, and that community starts bombarding us with papers, there's a chance you're going to see a proportionate increase in papers in that area published within Nature, because ultimately we're constrained to draw our papers from the papers that are submitted to us. Likewise, there are some disciplines which probably look at Nature, maybe even look at science and say, why do they never publish papers in my field? One possible reason is people in your field never actually submit the papers to that journal. So again, we don't have a complete free rein in picking and choosing what we publish. We are ultimately constrained by what's submitted to us. That's why we want to get as much of the good stuff submitted to us as possible, so we can then pick and choose.
Yeah, and I think just to add one quick thing to that, I mean, science uses the board of reviewing editors, which are academics who provide additional feedback on the paper before we decide to send it out for review or not. And I think the other thing to think about in both science and nature is we're looking for papers that'll be interesting to people who aren't in the field of the paper that it is. So, you know, we're publishing a lot of COVID papers that if they were done at a different time would be probably in more specialized journals. But lots of people in physics and chemistry and computer science are interested in COVID. So we're publishing those papers because we're a general journal.
Okay, thanks. So Andre has asked a question a while back. Andre, would you, Nevidomsky, would you please ask your question short? Keep it brief and please ask the question.
Yes. Yeah. So without necessarily delineating the difference between the editorial boards of Science and Nature, I'd like to ask the question to both editors. Do you feel that providing the editorial rejection without peer review places an inordinate power in the hands of one man or one woman in deciding the fate of the submission? Would it not be better if, under all circumstances, a submission was sent to, let's say, one professional reviewer, maybe a board member in the case of science, maybe external professional scientists in the case of nature, and their opinion be weighed in before the editor presses the button yes or no?
Yeah, so I mean, look, the professional editors who work for us have a lot of influence over the future of science. We try not to think about it because we can change people's lives if we say yes. There are a lot of papers that are not going to make it, no matter what, that we get. I mean, we only take 6% of what we get. We only send 15% out for review. So we want those folks to get an answer from us as quickly as possible so that they can move on. But that's a balance, or exactly why you're saying. But the reason that Dan Koshland put the board of reviewing editors in place at Science is to address exactly what you're saying. Now, one thing I didn't know before I got this job, I mean, I suspected, was how sophisticated the professional editors are. They're not like college professors because we all know a whole lot about a very narrow thing. The professional editors read papers for a living, and they have a broad remit, and they can see things in papers that we don't see. So I think their opinions are very sophisticated. But even with that, we do have the board of reviewing editors, which we probably send twice as much stuff to the board of reviewing editors that we decide to review. So that's 30 or 40% of what we get.
Yeah, and I would just add a slight difference for us because we don't have a board of reviewing editors. But for the vast majority of papers, it's pretty clear to the editors whether this is one that has a chance or doesn't have a chance with us. The papers that fall in the grey area in between, those are the ones where if we feel we need it, we bring in either more editors, or we do indeed contact somebody externally to get an opinion on it. But we don't have a set process for doing that. We do it when we as editors feel that we need that input in order to be comfortable with the decision that we're making. And as Holden said, because the vast majority are going to be turned down at some point, either before or after review, we want to minimize that pain and that time to the authors as far as possible so that they can go somewhere quickly and get that paper published.
Thank you. I think the next question I'm going to move to, he's been asking,
Can I add to that
raising his hand for a while, Robinson Okanigbuan. Sorry, I probably slaughtered the name, but please go ahead. Robinson.
Thank you. Thank you. Thank you. Yeah, thank you. Can you hear me? Okay.
Yes. Yeah.
The issue I have is most of us from African universities, we find it difficult to publish our work in the top journals in Europe because of cost of publication. So what assistance can you render to the authors from this part of the globe so that we can publish our work? When you look at the exchange rates, some of us have good work, but when you look at the cost of publication, we cannot go ahead. And that is just my question. So if I'm like now from Nigeria, I'm publishing, I want to publish an article in the Fiscal Review B. And when you look at the cost of publication, by the time you look at the exchange rate, it's quite high compared to Nigeria currency. So how, if you are from this part of the world, how do you assist us? That is my question. Don't you have a kind of rebate for authors from South Africa? That's my question.
Yeah, you're bringing up a really important point that I'm very passionate about, as I said earlier, which is, we have to have journals where there isn't a cost, and if we don't fight to preserve those, then this problem that you're outlining is going to just get worse. And I worry that the open access movement is going to drive us to more pay to publish journals, and that's money's going to come from researchers. And I'd rather take the money from the library of a very rich American university that has a big endowment, which I charge more than I charge smaller universities with smaller budgets. And that's actually a very progressive system. And the irony is a lot of these APC advocates think they're pushing for a more progressive system, but actually we already have a progressive system. We charge the universities with more money, more for their subscriptions. So unfortunately I have to go, but thank you all for including me. I had another thing at 1 o'clock, so sorry I'm late for that. But thank
No,
you all very much. Great
thank you
talking
very
to
much for coming on behalf of everybody. We have a few more questions. We'll see if we can squeeze some in. There's a question from Sam Carr. Would you like to ask the question of Gianfranco? You wanted to ask Gianfranco a question. Sam, go ahead.
Yeah, I just was curious about this explosion of scientists and them taking over the world. How much that's distributed between the obvious science that you can sell to the public, like biomedical things, and is there a big difference in the growth rate of that with science that is much more under the rug, like condensed matter physics, which basically the public don't know what's happening in at all?
Well, I think these numbers are available. It's not so easy to find them, but are available. I think all science has grown by far. Of course, some fields have grown more than others. In particular, in the second half of last century, biology has grown enormously. But I think that is a general phenomenon. But if allow me to say something, we are focusing too much on nature and science, because as I have shown, there are 33,000 journals, scientific journals. Nature and science, of course, are the top. But if you look at the number of papers we publish compared to the 3 million papers which are published every year, it's a tiny fraction. And in these 3 million papers, there are the real problems of modern science, which are predatory journals, papers which are reporting irreproducible results, often wrong results, basically frauds, and plagiarism, and so on and so forth. So many issues which were very little, had a very minor effect in science in the past, they are growing quite rapidly because of the low quality of the journals. So I think this is a very serious problem. So we should not look so much at the top journals, because finally scientific journals are providing knowledge to the society. And if a society cannot trust science, which is basically in a way certified by the peer review process, then we have a social problem. So science is no longer trustable by the society. So I think is a really an important issue, and that is probably comes to also with the question of education, and that we have to face, because the numbers are there. The numbers are very, very large. But we should not look only at the top journals. We should also look at the rest.
Okay, so one final question, because we really come to the end, and the directors have told me that it should be wrapped up because there's another talk coming up. Eagle Meyer, would you like to have asked the last question?
Okay, thank you. I have one question. I think it's for Laura, but maybe the other scientists on the panel. And this is what I consider is really the reason for the chase for age factor and higher impact factors. We as physicists, when we consider a guy for promotion or hiring, we have no problems in assessing the contribution this guy made for science. Reading the papers, exactly as Laura mentioned, as one of the ways. But eventually all hirings, promotions, fundings come up to a committee which involves scientists from different fields, even humanities, and they have to compare, files from different fields. And they are not able to assess the contributions by reading the papers. And, even all recommendation letters, are now so uniform that it's very hard for them to compare. So I think it's the pressure from above that actually they want all files to come up with a single number, so they can just compare the numbers and say, this number is larger than that number, so this guy is better than that guy. And age factor or some other weight, something weighted by impact factors and citations is something that they can easily calculate and compare. And this trickles down later to the physics department, because then if we have a guy that we think is a very good guy, but he will not be able to compete with other people because of that lower age factor or lower impact factors, that also impact the decisions within physics departments. And it also affects the individuals who now understand that in order to succeed in the long run, they have to chase those publications and numbers. How do you handle this?
So that's a very interesting question, Yigdal. Thank you for asking it. Let me premise that by saying when I'm asked to write a report for NSF or NAS, I will not prioritize that semiconductors are more or less important than superconductors or graphene. I refuse to prioritize. I just submitted a paper last night to PRX that required a general justification, a popular justification, and a technical justification. So I think what you're talking about is very important, and more journals are asking for these kinds of justifications. I think we have to educate our administrators that how wrong using a single number is, as was covered in many talks that we heard, outstanding talks that we heard here. And we have to push back and say, I can't prioritize biology over music, over whatever, but let's get together and discuss what these impacts are and the need for the university or the company or the laboratory. So again, we have to, as Henri is always fond of saying, it's our own fault, and we have to work very hard to fix it and not let anybody use to reduce anyone into a single number.
Thank you, Laura. I think in view of the time and the next upcoming talk, we have to end. Unfortunately, this could go on for hours and would be a lot of fun, but I'd like to stop here. I thank everybody, all the friends and colleagues who gave the talks, and I especially like to thank our guests, Karl Ziemelis from Nature and Holden Thorp from Science. We really appreciate you coming here. At some point, I would like to talk to you about how to publish a theory paper in Nature, but that's another story. Okay.
Thank you, everyone.
Good luck with that one.
JP, we're running a little bit late, and I suggest we have a 5-minute break before we delay you at the start of your talk by 5 minutes. Okay. Thank you, everyone. And this has all been recorded, so we will put it online so you can go back and have a look at it.
So if you want to retract anything.
Hi, everybody. Yeah. Thank you. Thanks for inviting me.
Thank you.
Thank you, Gianfranco.